In this video, I'd like us to discuss molar solutions. Now, first of all, I want us to define some very simple concepts, and one of it is the definition of a molar solution. Now, just from whatever I've written, it is one whose concentration is known. It is just a solution in which its concentration is known. Now, what do I mean by this word concentration? Or what is the SI unit of concentration? Concentration, the SI unit is molarity. And the molarity, the symbol is capital M or the uppercase M. So concentration is normally given in molarity as the SI unit. And what is molarity? It is the number of moles of a solid present in 1 liter, 1 decimeter cube, or 1,000 cubic centimeter of a solution. Now, if in case I have a solid in a solution, the number of moles of a solid in 1 liter, 1 decimeter cube, or 1,000 cubic centimeter of a solution is known as the molarity of that solution. So if I have, let's say, 0.1 moles in 1,000 cubic centimeter of water, that one is referred to as the molarity of that solution. Say if it was sodium hydroxide. Now, concentration is directly proportional to the amount of solute, or rather the number of moles of a solute. It means that as the concentration increases, the number of moles of a solute or the amount of a solute also increases. So I want us to do some very simple examples, and let's start with the first one. Calculate the molarity of a solution containing 4.0 gram of sodium hydroxide in 500 cubic centimeter of solution. Now, I normally give us students a very simple triangle that will help us discuss everything that we're going to tackle in this video. So if I have such a triangle, the number of moles of any substance is equal to the mass of that substance divided by the relative molecular mass of that substance. Now let's take, for example, I have the mass of sodium hydroxide. How do I get the number of moles of sodium hydroxide? I take the mass, the 4.0, divided by the molar mass. It means that I must calculate the molar mass of sodium hydroxide. And what is the molar mass? From these solutions that I'm having here, 23 for sodium, plus 16 for oxygen, plus 1 for hydrogen will give me 40 gram per mole. So the molar mass of sodium hydroxide is just 40 grams per mole. Secondly, I calculate the number of moles present in 4 grams of sodium hydroxide. And how do I calculate that? It is very simple. I take the mass of sodium hydroxide divided by the molar mass of sodium hydroxide. So it is 4 gram per mole. So the grams will cancel and I will remain with, when I take 4.0 divided by 40, will give me 0.1 moles of sodium hydroxide. So this number of moles of sodium hydroxide are contained in 500 cubic centimeter of a solution. And how do I calculate molarity? We said molarity, it must be in 1 liter, 1 decimeter cube, or 1,000 cubic centimeter of a solution. So I'll ask myself this question. If 500 cubic centimeter of a solution contains 0.1 moles of sodium hydroxide, how about in 1,000 cubic centimeter of a solution? It will be 1,000 cubic centimeter times 0.1 moles divided by 500 cubic centimeter. So the cubic centimeters will cancel. So in such a case, when I have such a solution, when I punch it in the calculator, I will have 0.2 moles per liter, or rather I can say 0.2 capital M, or 0.2 moles per decimeter cube. All of them are just equal and the same. So that is the concentration, or rather the molarity of sodium hydroxide in 1,000 cubic centimeter of a solution. Let's go to the next question. The density of sulfuric acid is 1.8 gram per cubic centimeter. Calculate the molarity of the acid. We are given the molar masses of the elements. Now, first I'd like us to understand what this entails. When I say or write 1.8 gram, 1.84 gram per cubic centimeter, what does it mean? It means that I have 1.84 gram in 1 cubic centimeter of a solution. So that is the understanding of the density. So it is just mass per cubic centimeter. In this case, it is in 1 cubic centimeter. So if I have such a mindset in my thoughts, how do I get the molarity of this acid? Let us keep it in mind that when I talk about molarity, I mean the dissolution or solution of a solute in 1 liter or 1,000 cubic centimeter of a solvent. And in this case, I am given mass per cubic centimeter. It means that this mass is in 1 cubic centimeter. So what is the amount of the solvent in 1,000, or rather, what is the mass of this solute in 1,000 cubic centimeter of a solvent? So I'll ask myself this question. If 1 cubic centimeter contains 1.84 gram of sulfuric acid, how about in 1,000 cubic centimeter? It will be 1,000 cubic centimeter times 1.84 gram divided by 1 cubic centimeter. The cubic centimeters will cancel, and what will I remain with? So the mass will be 1840 gram. So this is the mass in 1,000 cubic centimeter of solution. Now, if that is the mass in 1,000, what will be the number of moles in this 1,000? Keep it in mind, we said molarity is the moles of a solid in 1,000 cubic centimeter. I have the mass in 1,000. So how do I get the number of moles? The number of moles is calculated from the mass all over the molar mass. And I have the mass in 1,000. How about the molar mass of sulfuric acid? The molar mass of sulfuric acid will be equivalent to, from the formula, I have H2SO4, hydrogen is 2 times 1 plus 32 plus 4 times 16. The total will give me 98 gram per mole. So that is the molar mass of sulfuric 6 acid. So how do I get the number of moles? I'll take the mass, 1840 grams, divided by the molar mass, which is just 98 gram per mole. So when I punch that one in the calculator, I will get 18.775. Capital M. So this will be the number of moles in 1,000 cubic centimeter. Remember, this mass was in 1,000. Therefore, the moles will be in 1,000 cubic centimeter. So that is how simply we tackle question number 2. Let us get into the final one. Calculate the mass of 25 cubic centimeter of 0.2 molar sodium hydroxide solution. In this case, we are given the molarity and we are asked to calculate the mass. This 25 cubic centimeter is the volume of sodium hydroxide that we're going to use from this 0.2 molar solution. So first of all, I need to get the number of moles present in 25 cubic centimeter. Remember, whenever you're told 0.2 molar, it means that I have 0.2 moles of that solid in 1,000 cubic centimeter. How about in 25 cubic centimeters? So I'll say this: if in 1,000 cubic centimeter, I have 0.2 moles of the solid, how about in 25 cubic centimeter? It will be 25 cubic centimeter times 0.2 moles, everything divided by 1,000 cubic centimeter. The cubic centimeters will cancel, and I will, when I have that in the calculator, I will get 0.005 moles. So these are the number of moles of sodium hydroxide that is contained in 25 cubic centimeter of the solution. Remember, we are asked to calculate the mass of 25 cubic centimeter. From this triangle, how do I calculate the mass of anything? The mass of a solute is calculated from moles times the molar mass. Moles times molar mass. But what is the molar mass of sodium hydroxide? I calculated it somewhere, so I can use the same knowledge. So the number of moles of sodium hydroxide is 0.005 moles. When I multiply it by 40 gram per mole, what will I get? The number of moles will cancel. So when I have that one in the calculator, the answer will be 0.2 gram. So this will be the mass of sodium hydroxide. Thank you very much. I hope you enjoyed the video. See you next time in the next videos. Make sure you share, like, comment, and subscribe on the channel. Bye.